Hello everyone. In this video we're going to use a simple circuit that has resistors in series to introduce you to some basics of DC circuit measurement as well as Ohm's law and Kirchhoff's voltage law. So we're going to actually demonstrate how to measure a DC circuit with a DMM, and we're going to demonstrate Ohm's law and Kirchhoff's voltage law. So let's go ahead and get started. The components we're going to use for this tutorial include the Fluke 77 Mark IV multimeter. It's a DMM, and DMM stands for digital multimeter. We're going to use a solderer's breadboard. We have three 330 ohm resistors and a power supply and a couple of jumper wires to connect the circuit to the power supply. First thing we're going to do is actually check the resistance of the resistors. These resistors have a gold tolerance band, and so that means they should be a plus or minus 5%, or have a resistance between 315 ohms and 345 ohms. So as you can see, we have the digital multimeter placed on the ohms measurement, and just place them together. You can see that, okay, we're seeing 0.1, 0.2 ohms between the two terminals, and we can look at each one of these resistors separately. Notice I have the jumper wires disconnected from the power supply just so that that doesn't influence these measurements. And you can see 327 ohms, that's within our tolerance. Here we have 325 ohms, 325.9, and for this one we have 326.1. So all three resistors are within the 5% tolerance of 330 ohms, and now all three of them together should add the sum of each individual resistor will be our total resistance across the circuit. Okay, and so we have, you can see it says 0.981 kilo ohms, or 981 ohms. So just let's look at this real quick. We have 327, let's say 328, 325, let's say 326, and they're 326. So they're all a little bit lower than 330, and so we have a little bit less than what we'd expect from the nominal number. Nominal number will be 990 ohms, so we see 981. So that's the basic of the resistance values for resistors in series. So the sum of the three resistors will add up to the total resistance across the circuit. So next we can plug this in, and I'm going to plug it into 12 volts. I have my black wire connected to ground and a red wire connected to 12 volts. I'm going to turn this on, and then we switch our multimeter to measure volts, and you see there's two settings here for voltage measurement. There's one with a little wavy line, that's for measuring AC voltage, and there's one with a straight line, a straight dashed line, that's for measuring DC voltage. And you see up here it says volts DC. And so let's just make sure that it really is 12 volts, and so I'm measuring across the circuit. It says 11.98 volts. That's pretty darn close. And if I measure the voltage across each resistor, you can see I have 4 volts there. I have almost 4 volts there, and again almost 4 volts there. So the sum of those three voltages adds up to the total across the circuit. Now, what's interesting is when we get into Kirchhoff's voltage law, it basically says the algebraic sum of the voltage drops across all the components in the circle will be equal to 0. And that might not make a lot of sense until you look at the polarity of our measurement here. So notice that if I measure this way across this resistor, I get 3.998 volts. But if I switch these around and I measure, you see now I have a minus 3.995 volts. So you can see it's changing a little bit, but it's close enough. So if I keep that same polarity across the entire circuit, I will get, and I add up all those measurements, it should equal 0. Now that's Kirchhoff's voltage law. So let's just do that. So I've got red on the right. Okay, so we already did this. We got 4 there, 4 there, 4 there. And now I have to then put my red probe, my positive lead here, and this here. You see I have a minus nearly 12 volts. So we have 4 plus 4 plus 4 minus 12 is 0. So we've proven Kirchhoff's voltage law. Now to prove out Ohm's law, we need to reconfigure our multimeter so we can measure current. Remember, Ohm's law says that voltage equals current times resistance, or in this case we're actually going to look at it from the standpoint of current equals voltage divided by resistance. So we've measured our voltage at about 12 volts and our resistance across the circuit at 981 ohms, and that means we should see a current of about 0.012 amps or 12 milliamps. So first thing to reconfigure I'm going to turn the circuit off, and then I'm going to change the setting here. No, before I do that, I'm going to change this, turn this off, and change this probe location on the meter. See, there's 2 options here for measuring current: 400 milliamps or 10 amps. And so we said we think this should be 12 milliamps. So that's the one we're going to use right there. And this is fused. Okay, and I'm going to add some alligator clips onto these to make this a little easier to hook up. Now, one thing to note is that the current, since this is a single loop, or the circuit is a single loop, the current will be the same throughout the circuit. Okay, so I have now attached, basically inserted the multimeter into the circuit so that it's, well, as long as this stays connected, it's inserted. There we go. So now the multimeter is actually part of the circuit now, and that's how we need to configure it to measure current. Important thing to keep in mind: if you now try to measure voltage with this, bad things are going to happen. You might blow the fuse of your multimeter. So we're going to place it over here on milliamps, and again, you can see that we have an amp measurement, we have a milliamp measurement, and hopefully you can see this in the video. We have 2 options here. We have a squiggly line that's white, and that's our primary, and it's milliamps AC. You can see it says that up there. We also have this like the voltage, we have this straight line with the dashed lines, and it's in orange. So we press this button right here, and now we have milliamps in DC. And if we flip this on now, things go boom. No, just kidding. So now we have just what we expected to see. We said we were expecting to see 12 milliamps, and we're seeing about 12 milliamps. So with that, we have now proven Ohm's law. So in summary, we've gone over some of the very basics. We've measured resistance, we've measured DC voltage, we've measured DC current, and we've proven Kirchhoff's voltage law, and we've proven Ohm's law. If you like this video, please click like. It motivates me to make other videos just like it. If you want to find out when I post more videos, please subscribe. You can also read about completed projects on our website spaztech.net or spaztech.com. On our website, we include details of how we did some of the projects that are on these videos, and some of the source code that you can use yourself as much as you like. If you want to track progress of projects we have going on step by step, be sure to check out our pages on Twitter and on Facebook.